Hello guys and welcome back to our computer networks course. So in this section we will be beginning with TCP, that is your transmission control protocol. So let's get into it and see a overview for it, right? So let's have an idea of what TCP actually is, right? So like we have already studied what our UDP is, right? By this time we know what our UDP is, and we know that it is what a transport layer protocol, right? It is a transport layer protocol. TCP is similar in that manner, but it is also very different in the fact that it is stream oriented, right? So if you remember, our UDP used to be message oriented, right? But our TCP is stream oriented, right? So both of these, the common link between UDP and TCP is what? That both are transport layer protocols and both are process to process communication methods, right? So what happens is, in both TCP and UDP, these are both what? Transport layer protocols, right? That was my first point. And my second point is that they both take care of processes, right? They both make sure that information reaches the process, right? So that is what your process to process communication means, right? Host to host would be what? That this device is communicating with this device, right? It does not care about who in that device would get that information, right? All it cares about that this device got it, right? So for process to process, we care about which process got it, right? So information sent by this process will only reach the certain process that it is trying to send information to, right? So for example, if WhatsApp is trying to send some information to this guy's WhatsApp, it will only reach his WhatsApp, right? It won't reach Facebook Messenger or Instagram message, right? It would only reach to WhatsApp, right? So that is what your process to process communication means. All right. So what does stream oriented mean, right? So do you remember what a UDP was? A UDP was message oriented, right? And that meant that we are bursting data, right? That we are sending burst data, right? So what that means is, I send something as a message, right? I send burst data, right? I send, then I stop, I send, then I stop, I send, then I stop. That is what was happening in our UDP. And we said that this is fairly unreliable. This is unreliable, right? So the only thing that UDP ensured was that your messages are isolated, right? The messages would not be intermingled in any sort of way, right? So if I send hello Pep as two messages, hello and Pep, I might either get hello Pep or I might get Pep hello, right? The order might be changed, but the messages would be absolutely isolated, right? They would not mix up. It was also unreliable, right? So I might have just gotten hello or just Pep, right? Or nothing at all. Those are also things, right? That could have also happened. This was our UDP, right? So moving on to our TCP, we said that this is stream type, right? Stream oriented. And what that basically means is, if I send hello Pep, right? I might receive hello Pep. I might also receive hell OPEP. I might receive hell OP and EP, right? This is like, I could receive it in any segmented manner, right? But the thing is that order would be maintained, right? I will not get Pep hello, right? I might get hell O. I might get something of this sort, but I will never get this. Okay. So that is what my stream oriented is, right? So we are sending a stream of bytes that have been segmented, right? So segmentation boundaries are not the same as your message boundaries, right? The segmentation happens to optimize stuff, and message boundaries are not maintained in our TCP, right? So moving on, we also say that it is a connected process. That means that it is a connection oriented process, right? So do you remember when we did our UDP, right? When we did our UDP, we said that I want to send something, so I just start sending, right? I send stuff, and this guy would also send stuff, right? I would send stuff, I don't care. We just don't care, right? We just send stuff if we want to send stuff, right? There is no acknowledgement, no nothing else, right? That does not happen in TCP, right? So in TCP, it is a connected process. That means that we first establish a connection, right? So matlab this is so UDP was the example of your postal services, right? So when somebody sends you something by post, they just send it, right? They don't care. Matlab you would receive it or you would not receive it. It might reach your home, it might reach somebody else's home, right? So those are all like UDP, right? But when we're talking about TCP, it is more like a phone call, right? So you dial a number, there's a connection, right? You dial a number, there's a connection, and this guy says, okay, this guy picks up, right? You call, this is you calling, this is that guy picking up, and this is you acknowledging that pickup, right? So, what happens is this is called a three-way handshake, by the way, right? So I say hi, you acknowledge my hi, and you say hi back, and then I acknowledge your hi, and then we start talking, right? That is what actually happens. So, what happens is you send a sync package, right? And this guy in return would send a sync package and also acknowledge my sync package, right? Then I would acknowledge his sync, and then after that acknowledgement we can have normal communication, right? That is how our TCP makes a connection, right? It also would have to break a connection, right? Those are your pin packages, right? Pin is what tells us that okay, let's stop the connection right now. All right. So we will discuss all these things later on in much more depth. But for now, all you needed to know was that there is a connection that is being maintained, right? So you form a connection, and only then do we begin with our communication, right? Let's talk about this as well. So it is full duplex, and that means so we probably have studied about what duplex is, right? So when we say it is full duplex now, it means that one guy can send and receive at the exact same time, right? So at a certain point of time, I can be sending data as well as receiving data, right? So the communication can happen in two way. I wouldn't have to wait for I wouldn't have to wait to send data because I'm receiving some data, right? Or I wouldn't have to wait to receive data because I'm sending some data, right? So these two can happen parallelly. That is what full duplex basically means. So again, we'll be going into all of these things in depth. But for now, this is just an overview, right? So you need to get an idea of how things are working so we can proceed with things, right? Then we're also saying that it is reliable, right? So UDP was extremely unreliable, right? It did nothing. It had a checksum, and that was it, right? And even this checksum is not mandated, right? Even this checksum is not mandated. It can be there and it cannot be there. It doesn't matter, right? And that was all the reliability UDP had. In TCP, it is quite different, right? We are going to have many more things, right? We already have maintained a connection, right? So we know that things are reaching. We have acknowledgements, right? We have your checksum. We have many more things, right? So we will be discussing that in TCP, right? In TCP, we have a lot of things, right? So we have your checksum, right? We have acknowledgements, right? We also have your flow control. We also have error control, right? So all these things were not there in UTP, right? But they are in TCP, right? So much more reliable than UDP. However, since we are doing all of these things, it is indeed slower than UDP, right? So UDP was just send, and I don't care, right? So that was viable for live stuff, right? So for example, if I'm streaming live, I would not care if one frame does not reach, right? If two frames do not reach, I care that the current frame should reach in the fastest manner, right? So that is when UDP is very viable. TCP would be viable when you want to make sure that okay, my information reaches, right? My information reaches and it reaches properly and it is not corrupted and all those things, right? So basically everywhere else. So let's move on and see all the other things, how TCP works, how things are maintained, how your messages are sent, how a header is made, and how your checksums are calculated. All right.